Today we're going to talk about a little more on our congruent triangles. We've already done quite a bit with congruent triangles already. We're going to take it one step further. So when we're talking about congruent triangles, we're trying to figure out if two separate triangles are actually the same triangle. And we have a couple of ways that we've used to prove that so far, and we're going to add one more today. And we're not just going to prove congruent triangles this time, but we're going to also start setting up equations with our congruent triangles. So the three ways we've already talked about to prove triangles congruent are side, 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 angle, side, angle, side, angle. And we're going to add angle, angle, side as well today. We also have ways that don't work. Oops. I don't know, I put a question mark there. I need to put a colon. Knowing three angles is not enough, and knowing a side, and an angle is not enough. So again, if we're trying to prove two triangles congruent, just knowing those three pieces of information is enough, because if I know three specific sides, I can only draw one triangle. Or if I know a side and an angle in between the other side, I can only draw one specific triangle. But with angle, angle, we saw angle, angle, angle. I could draw a triangle, but I can take that triangle and make it bigger or smaller. But that doesn't change, except that I accidentally changed the size of the triangle instead of just making it bigger or smaller. But if you just make the triangle bigger or smaller, it doesn't change the size of the angles, it only changes the size of the sides. Or side, side, angle, I looked up a website so we could see. Right now, these two triangles are congruent. But if I click on Show Other Triangle, I used that same side length to create a second triangle. So it's possible to create more than one triangle knowing an angle, a side, and another angle. So angle or side, side, angle does not work as well. So we've already proved a lot of triangles congruent, but they've always been separated. What if we have some triangles together? Sometimes there's information we need to assume. So the most common cases of assumed information are when we have two triangles connected like this. So yes, we have two triangles connected, but we also have two lines crossing. And we know something about lines crossing. We know that these angles are the same. They're vertical angles. So even if I didn't actually write out the angle symbol for those, we could write it in ourselves because we can assume, hey, those are the same angles. The second one where you often have to assume information is when we have two triangles connected on one side. So yes, that's a square, but if we look at the individual triangles, we can assume that side in the middle is the same length for both triangles because they're using that same line. So if I separated them after, then that side length is still the same. It's just shown on one picture instead of two. So sometimes there's assumed information that they assume you know and they don't actually identify for you. So let's look at a problem. Let's say I have this information, and I know all the picture has given me. We do need some letters so we can name our triangles. So we're trying to decide, are those two triangles the same triangles? Is ABE the same as BCD? And what order do we put it in? So they've only given us two pieces of information. They gave us sides that matched. They said side AE here and side CD match, and then angle A and angle D match. But they didn't tell us one last set of information. All of those require three pieces of information. If we couldn't find a third piece of information, we would say, there's no way to prove these congruent. Maybe they are, maybe they're not. But we know we can assume angles here, angle CBD and angle ABE, are the same because they're vertical angles. So we had to write that in ourselves. Once we do that, we can make our triangle congruence statement just like we've been doing. I would say triangle ABE is congruent to, now the second triangle must be done in the same order. A had a mark showing that it was the angle with one mark. So we're going to look on the other triangle. The angle with one mark is D, so triangle D. B had two marks on its angle, and it's used twice, so DB. And then E had no angle mark at all, and C has no angle mark at all, so triangle DBC. Then we have to decide, well, how are we proving them congruent? How do we know AB is actually congruent to triangle DBC? Well, we look at the information that's given. The two green was an angle, the one black mark was an angle, and the one mark in between C and D was a side. So we've used angle, angle, side to prove that those two triangles are congruent. If I have two angles that are defined, angle, let's say the angle's 50 and the angle's 30, and I have one side that's 5 inches, I can only draw one triangle. There is no other way for me to draw a triangle. I can't have multiple versions using that information. So it proves that those triangles are completely congruent. So we can also be given the fact that two triangles are congruent, and we can name all the specific parts that are congruent. Let's say we know that triangle FBD is congruent to triangle SQB. And I purposely put them not in alphabetical order because I wanted it to be a little more confusing than just having it in alphabetical order. So we're going to prove. Okay, I got interrupted, so I'm going to have to splice some videos together, so there's a weird break, that's why. So, triangle FBD congruent to triangle SQB. Now I don't even need to draw these out to identify what parts match. We know these make up an entire triangle. And I am going to draw it just so you can visualize it, but you don't really have to. So we have triangle FBD. We know angle F is there, angle B is here, angle D is here. We know F to B makes one of the sides, B to D makes a different side, D to F makes another side. So it's the same for SQV. So we're going to name all the specific parts of the triangles that are congruent. We're not just going to say the entire triangle is congruent. I'm going to say, I want to know, what is angle F congruent to? Well, we know they have to go in the same order to be congruent, so F has to match with S. So we know angle F would be congruent to angle S. And we know angle B would be congruent to the next one, so angle B has to be congruent to angle Q. Angle D has to be congruent to angle V. Well, we could also name all the sides that match. We're going to name first side B. So to name a side, we use the two letters on either end of the side. And we put a line over the top to say, hey, this is a line segment. We know it's congruent to the other triangle, and again, it has to be in the same order. So without even drawing the other triangle, I know F was first, B was second. I've got to use the first and second one on SQB. So first came S, second is Q. So side FB is congruent to side SQ. Then we do it again, B to D. Side BD would be congruent to, so B was in the middle, D was last. We use Q because that was in the middle, B was last. Now the last one is D to F. We have it drawn here. When we look at this, D to F actually goes last to first. So we have to say D to F, and we have to use the last one on the second triangle to the first letter on the second triangle. So V is the last letter of the second triangle, S is the first letter. So we can name actually each individual part that is matching, not just take a triangle and say that the entire two triangles match. And the last thing we can do is we can actually say, well, if these two triangles are congruent, we can set up an equation to solve for x if they've given us some expressions on the triangles. So there is our triangle. And in the instructions, I'm going to state that triangle ACD is congruent to triangle ABD. So we already know they're congruent. We don't need to make a statement. I'm not asking you to prove anything. I've told you they are congruent. But after we know they are congruent, we're going to find x. So if we know these are congruent, we want to see, well, how does side AC compare to side AB? Are they the same? Should they be different? So let's look at our triangle congruence statement. We're trying to figure out how does side AC, so A to C, compare to A to B. Well, we notice, hey, those are in the same spots on our triangle congruence statement. That means they are the same. That's why we put them in that order to say A to C is the same as A to B, and C to D is the same as B to D. So if we know they're the same, we know we can set them equal to each other. After I've set them equal to each other, now I just solve this equation. A lot of what we've done is set up equations and solve them. So if I'm going to get x by itself, first I need to get rid of x so that we have only one x on one side instead of an x on the left side and an x on the right side. So I'm going to minus x and bring down 7. 2x minus 1x is 1x. And now we just have to do our opposites. Opposites of minusing 3 is adding 3. So we would get x equals 10. Again, that's not the actual side length, that's just x. If I wanted to know the measure of AC, I'd have to take that expression, x plus 7, and plug in the answer we just got. So it's 17, and if we're measuring an actual distance, 17 inches or feet, I'd have to tell you what units we were working with. Okay, so let's try one more. then we'll be done with the notes. See example 4. We got a room. Let's say we know triangle PQR is congruent to triangle STR. Again, we're going to find x. So let's say we know that this angle is x squared minus 6x, and we know that this angle is 4x plus 24. Now again, we know they're congruent, so we know each individual part is equal to each other. Most of these are pretty straightforward, and they will be equal to each other. Some of them might not be quite as straightforward, and maybe we need to use a little more information, like maybe they gave me 2 angles in the triangle and I have to find the third. But this one, we look at Q, we look at T, they're in the same spots, so they are congruent, so we can set these equal to each other. We have 4x plus 24 equals x squared minus 6x. Now we have to think back how to solve something like this. We have an x squared. That makes it a lot harder to solve. So when we add an x squared, we know that's a quadratic function, and we have to solve it by getting it equal to 0 first. So I'm going to get rid of the 4x, and I'm also going to get rid of the 24. I'm going to line up the 4x with the 6x because they are like terms. But I'm going to put the minus 24 on its own because it doesn't have any like terms. So we get x squared minus 10x minus 24. Now that we have it equal to 0, we could use quadratic formula to solve this. We could use box method to solve this, which is factoring. We can use graphing. We can use completing the square. We can't use square roots because it has a middle x term. So let's do factoring. Let's do the box method. But we talked about the fact that we can actually skip the box method if there is a 1, if there is a 1 in front of x squared. So I'm going to skip the box method. We know our answer should be 2 parentheses when we factor. And we know the only way to make x squared is x times x, so the first one in each parenthesis has to be x and x. But we have to decide what numbers multiply to be negative 24 and add to be negative 10. Now you have to be very careful because you might think 6 and 4. But the problem with that is one of these only has to be negative. To multiply to be negative 24, one has to be negative, one has to be positive. So negative 6 times 4, yeah, that's negative 24, but negative 6 plus 4, that's negative 2. So those don't work. So we're actually going to use negative 12 and 2. Now again, we're skipping the box method just to save us some time. We've had a lot of practice. If that was a 2x squared, we have to use the box method. But when it's just a 1, I can automatically just put those factors into my parentheses without doing the box and doing the greatest common factor. After we put it in the 2 parentheses, then we had to do our t-chart to solve. So we set each individually equal to 0. And then we do our opposites. We would add 12 to both sides. We get 12 equals x. We would minus 2 to both sides, so x equals negative 2. So then we would have to check and make sure both answers make sense. If the actual angle is negative, it's not going to work. Right now, the angle is we don't know without plugging it in. We only know that x is positive 12 and x is negative 2. So we're going to try plugging it in just to make sure that either both make sense or maybe throw one out if it doesn't make sense. So we're going to see what happens when we plug in 12, make sure the angle we get out is positive. So 4 times 12 is 48, plus 24 is 92. No, sorry, I think I did my addition wrong. 8 plus 4 is 12, 6, 72. Sorry about that. Then we're going to check our next one. 12 squared is 144. 6 times 12 is 72. 144 minus 72 is 72. So that's fine. We're happy if the angle comes out positive. So 12, it works. We're going to see if negative 2 works as well. So everywhere I see x, I'm going to plug in negative 2. So 4 times negative 2 is negative 8, plus 24 is 16. Negative 8 plus 24 is 16. Negative 4 squared is positive 4. Negative 6 times negative 2 is positive 12. That also works, 16. So that means with this particular triangle, we actually have 2 possible answers. We could have the angle be 16 degrees, or both angles could be 72 degrees. And it would still work out for these to be congruent if our angle ended up being 16 degrees or our angle ended up being 72 degrees. Okay, I will see you guys tomorrow.